In this video, we're going to talk about right triangle trigonometry, specifically SOHCAHTOA. So if we remember from geometry, when we were given a triangle, we would talk about a certain theta or angle. In relationship to that angle, there is an opposite side, which we abbreviate with O. There is an adjacent side, which we abbreviate with A, and then across from my right angle is my hypotenuse, which we abbreviate with H. And all of these relate back to this mnemonic device, SOHCAHTOA. So SO stands for that sine is, I shall just write up here, my opposite over my hypotenuse. Ka refers to cosine is adjacent over hypotenuse, and toa refers to tangent is opposite over adjacent. Now, on this right side are our reciprocal functions, meaning the flip of the original functions. So cosecant is the reciprocal of sine, so it's going to be hypotenuse over opposite. Secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. Cotangent is the reciprocal of tangent, so it's going to be adjacent over opposite. And so now we're going to use these relationships to label sides of a triangle and talk about their ratios. So let's say I give you a triangle and we're going to label it 3, 4, and 5 with a right angle here, and we're talking about theta here. So if theta is there, that means this is my opposite side, this is my adjacent side, and this is my hypotenuse. So if we're talking about sine, we're talking about opposite over hypotenuse, so my sine would be 4 over 5. If we're talking about cosine, that's my ka, or my adjacent over my hypotenuse. So that's going to be 3 over 5. And then tangent is toa, so opposite over adjacent, which would be 4 over 3. Now, on the side are all my reciprocal functions. So cosecant is my reciprocal of sine, so that's going to be 5 over 4. Secant is the reciprocal of cosine, so it's going to be 5 over 3. Cotangent is the reciprocal of tangent, so it's going to be 3 over 4. Now, in this situation, I gave you all three sides. But if we were missing a side, we would have to use our Pythagorean theorem. So Pythagorean theorem comes from helping us find a missing side in a right triangle. And typically we label this triangle ABC, and then we use the Pythagorean theorem, which is a squared plus b squared equals c squared. Or sometimes we refer to a and b as our legs, and then we call c our hypotenuse. So we could also say leg squared plus leg squared equals hypotenuse squared. So let's go through an example. Let's say I gave you a right triangle and I tell you this side's 5 and this side's 13. So we don't know this side, so we'll label that B. That means I could solve for this by doing 5 squared plus b squared equals 13 squared. Now I could have also labeled that missing side A. A and B are interchangeable, but C always has to be the hypotenuse. So first I would square each of these values. So we get 25 plus b squared equals 169. I would then subtract 25. And then I'm going to take the square root of both sides, so b is going to equal 12. And so my missing side would be 12. Now, once I found the missing side of the triangle, I could use that to then find my 6 trig functions like we did above. So this is kind of what we're going to combine in the last two problems. So in number 2, I'm going to give you that theta is here. Here is my right angle. And I'm going to give you sides 5 and 6. So we need to solve for my hypotenuse, or that's missing side. So we're going to use 5 squared plus 6 squared equals x squared. So 25 plus 36 would equal x squared. So 61 is going to equal x squared. Now to get x alone, I'm going to take the square root of both sides. In this case, 61 does not square root, so we're going to leave it as the square root of 61. Now that I have all three sides of the triangle, I'm going to fill in my SOHCAHTOA. So sine is opposite over hypotenuse, so 6 over square root of 61. Cosine is adjacent over hypotenuse, so 5 over square root of 61. Tangent is opposite over adjacent. Now, cosecant is the reciprocal of sine, so it'd be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. Cotangent is going to be adjacent over opposite. So this is going to be square root of 61 over 6, square root of 61 over 5, and 5 over 6. All right, let's do one more example. So now in this example, they're telling me that the cosine of theta is 3/4. So what does that mean? Well, first, let's label where theta is. Let's say theta is here. Here's my right angle. So if we're saying the cosine of theta is 3/4, I know that cosine is my adjacent over my hypotenuse. So that means my adjacent side, or the side next to my angle, would be 3, and my hypotenuse, or the one across from my right angle, would be 4. So that means the side that I'm missing is my opposite. So I would need to do my Pythagorean theorem to find that missing side. So I have 9 plus x squared equals 16, minus my 16, x squared equals 7. 7 does not square root, so my missing side is just square root of 7. Now that I know those missing sides, I can fill in my trig functions. And I'm going to fill in my SOHCAHTOA. So sine O ka toa. So square root of 7 over 4, 3 over 4, square root of 7 over 3. Then I'm going to do the opposite. So ho, ha, ao. And so 4 over square root 7, 3 over, nope, not 3 over 4, 4 over 3, and 3 over square root 7.